Hello, good morning, and a very warm welcome to everybody. It's really with great pleasure that we have so many engineering colleagues taking time out of their schedules to join our webinar today in order to hear a presentation on how artificial intelligence is impacting engineering design. And we appreciate you all very much spending your valuable time with us today. For those that regularly engage with our specialized engineering recruitment services, it's marvelous to see you again. Thank you so much for your ongoing support and great collaboration. For those that don't know us so well, or it's the first time to join us, you are also extremely warmly welcomed to today's webinar, and we look forward to getting to know you better. My name is David Armstrong, and together with my engineering colleagues here at Australia-wide Engineering Recruitment, we very much hope that the next hour will prove to be an interesting and thought-provoking session. Please do note that we are recording this to allow those that have missed the live session the chance to listen to this webinar later at their convenience. Here at Australia-wide Engineering Recruitment, where we've been operating for 45 plus years, under the premise of engineers engaging with engineering candidates in order to subsequently fill a range of engineering vacancies for our clients right across Australia and even occasionally some overseas. With my colleagues, we're always interested in technology trends and the changes in engineering, be it the type of roles or the changing functional aspects of engineering requirements. With that in mind, we thought a topic on how AI is impacting engineering design might trigger an interesting conversation. Now I'd like to introduce our presenter, who has very kindly agreed to participate and for creating and shortly delivering his presentation. Professor Xiang is currently a full professor and the Dean of Digital Research at Swinburne University of Technology, based here in Melbourne. He is driving the university digital research strategy and leading a group of talented researchers to help industry partners solve complex problems by digital transformation and innovation. Professor Xiang founded Swinburne's Digital Research Innovation Capability Platform to develop suitable digital technologies and translate these into real-world applications. Professor Xiang will introduce the topic of how AI is transforming engineering design and will highlight the potential benefits and advancements artificial intelligence brings to this field. He will kindly showcase examples of AI-driven optimization solutions and improved productivity and AI-driven designs tailored to specific user needs. Following the presentation, there will be a short question and answer session. So please do use the Q&A functionality at the bottom center of the screen to send us your questions anytime throughout the session, and we will attempt to answer as many as time allows. Without any further delay, I would now like to hand over to our friend Professor Xiang to commence the presentation on how AI is impacting engineering design. Thank you all.
Thank you, David. Hello, everyone. My name is Xiang. I'm from Swinburne University of Technology. So let me just share my screen before I can share the presentation. Okay, can everyone see the screen okay? Okay, good. I want to thank David and Stephen from Australia-wide for organizing this event and giving me the opportunity to speak to you as my brilliant guests. So the presentation has been done previously with the Professor Pat Rajiv from the Department of Engineering at Swinburne University. So Pat is not available today, but I'm more than happy to share this presentation with you. So the topic is about AI and engineering. So in the next couple of minutes, I'm going to share Our experience on AI and engineering research from Swinburne University and share with you how this can transforming the engineering field. So I begin today by acknowledging the traditional custodian of the land on which the Swinburne University Hawthorne campus is landed in, and I pay my respects to their elders past and present. I also want to extend that respect to Aboriginal and Torres Strait Islander nations today. So what is AI, artificial intelligence? So that's a very simple question, but this is also a very complex question. So we have seen computer science development over the past decades, and we have also evidenced the development of computer systems that can perform tasks that typically can replace human intelligence. So we have seen that the computer or the IT technologies perform a lot of problems solving tasks. For example, we can see that the computer systems can learn from our past experiences. They can recognize some patterns. They can even understand the natural languages, can process the images, videos, and help us to make better decisions. So we can call all those different types of technologies under this umbrella. We call them as artificial intelligence. So they are intelligence, but they are artificial because they are generated by computer technologies. So one subset of the AI technologies is called machine learning. So why we call it as a machine learning? Because those are the algorithms that run by the computer machines, and they can learn from the past. So they can gather information from the data that is can be learned by the machine, and those algorithms can make predictions or decisions based on those data. So it is a critical component of many AI applications. So machine learnings are those learning algorithms based on the past. And the typical machine learning algorithms include supervised learning or unsupervised learning or reinforced learning. I can give you an example of supervised learning, unsupervised learning, and reinforced learning. Because those are supervised learning, we label the data for learning processes. So we call it as supervised learning processes. And unsupervised learning does not require any data labeling. So we just feed the algorithms with a bunch of unlabeled data, and the learning algorithms can perform the clustering of the data and make the recommendations or decisions. And the more interesting learning process is called reinforcement learning, because those learning can guide themselves and reinforce those learning processes. So we can see that the machine learning algorithms have become more and more powerful, but we also got a lot of ethical and societal concerns, because nowadays we can see that those AI algorithms can make a lot of decisions for human beings. However, they also create a lot of privacy or other concerns of using the AI, and especially on those mission critical applications, such as autonomous weapons. So there are a lot of ethical concerns. So on one side that we are aware about those ethical and societal concerns, but on the other side, we are trying to improve the preciseness of those AI algorithms. So The trend are two ways. One way is that we are aware about those ethical concerns, and on the other side, we really want to improve the AI algorithms and trying to improve those processes and trying to make them really usable. So I guess that's pretty much about the artificial 101. And because those AI algorithms are so popular, and they has become a revolutionary tools and has transformed the ways that people live and work in modern society. With the help of the AI, people nowadays can collaborate with others. For example, people can use AI to share data, to streamline their workflow. Today, people can work remotely via data and communication. This means people can access their data and collaborate with the team members from anywhere in the world, and also with those intelligence generated by the machines. AI is transforming industries by providing tools to improve productivities. So nowadays, we can see the changes in different vertical domains, such as health, finance, agriculture, transport, and manufacturing. So we can utilize the AI as a tools to do different types of tasks. Those include advanced data analytics, visualization, collaboration online, and project management. With the help of AI and machine learning algorithms, people can identify patterns and transform their traditional ways of working. And previously, it is very difficult for people to detect traditional trends by using those traditional algorithms. But nowadays, with the help of AI algorithms, many tasks has become easier. We have seen the changes in different industry domains, and we can expect AI to become more user-friendly and accessible to people from all backgrounds. And these systems will continue revolutionize the way that we live and work and advance our understanding of the world around us. So why AI is so important? I can give you a few points why AI is so important, because in an increasingly interconnected world, AI can address complex societal challenges. So from healthcare and climate change to education to cybersecurity, it provides the tools and insights necessary to find solutions to those most important problems of our time. The second point is that AI is a very powerful driver to our economic growth and workforce. So AI underpins the development of those tech companies, creating jobs and contribute to economic growth. It can enable the efficient and competitive industry across different sectors. So in summary, AI is a transformative force that underpins the progress, and it can enhance the quality of life for everyone. So let's see what are the potential benefits and advancements that AI can bring to engineering. I summarize those in those different fields. So, for example, in the design optimization, AI can assist in the design process by running simulations and algorithms to optimize product design. They can lead to more efficient structures or systems, and they can reduce material and energy waste. In predictive maintenance, AI can predict when the equipment or machinery is likely to fail, allowing for preventive maintenance. This not only reduces downtime, but also extend the lifespan of your assets. Automation through AI can streamline routine and repetitive tasks, enable engineers to focus on more creative and more complex aspects of their work. And this can result in increased productivity and faster project completion. Quality control. AI-enabled vision systems and quality control algorithms can identify defects and anomalies in real time, and they can ensure that products meet their quality standards with those assistance from the AI. Energy efficiency. AI can optimize energy consumption in manufacturing processes and building systems, and reducing energy costs and environment impacts. Engineers can also use AI to design and implement sustainable solutions, reducing the environmental footprints of engineering products. AI can also support remote monitoring. Engineering can remotely monitor and control systems and equipment, which is particularly useful for infrastructure in remote or hazardous locations. Nowadays, people use those cameras and drones to do remote monitoring. Customization. AI can help tailor engineering solutions to specific needs and constraints, provide more personalized and efficient results. Safety advancement, cost reduction, collaboration with the AI can also produce a more quality and efficiency. Last but not least, resource management or AI algorithms can help optimize scheduling, resource allocation, and product management, ensuring efficient use of time and resources. So in summary, AI has the potential to revolutionize engineering by improving efficiency, accuracy, sustainability, while enabling engineers to tackle more complex and challenges and push the boundary of the innovation in the field. It offers a promising future for engineering that helps both traditional practices and cutting-edge technologies. At Swinburne University, we have a digital research platform, and our overarching aim is to position Swinburne as an internationally renowned institute in digital research, and we help our industry partners to solve their industry problems in different fields. So currently, we have 6 research labs, including Intelligent Software Systems Lab, Internet of Things Lab, Cybersecurity Lab, Intelligence Data Analytics Lab, Advanced Visualization Lab, and Blockchain Innovation Lab. So we have been working with our industry partners in different fields. We solve real-world challenges with our industry partners. We have a very diverse and inclusive team, and they are the talents who are the key drivers of research excellence and innovation. So we have those are talented people working on different fields, including health, manufacturing, engineering, construction, or different types of fields. And on the other side, we also have our very innovative engineering departments. I just want to mention that our civil engineering and computer science, both civil engineering and computer science and engineering are ranked as the world top 100. And the Center for Sustainable and Infrastructure and Digital Construction is a group of people who can develop innovative structural systems, innovative construction materials, digital design and construction, automation, and urban environmental and transport systems. So we have a combination of computer scientists and also civil engineers within this group. Next, I can give you some examples on how the engineering can transform the traditional engineering landscape, and how AI can optimize engineering designs. So first of all, we have heard a lot of things about ChatGPT. ChatGPT is one example of a generative design. Because by the improvement of natural language processing power, the AI-powered generative design software can create different types of design options based on defined parameters. This can allow engineers to create a wide range of design solutions. And we can also utilize AI for simulation and analysis, because AI can perform different types of simulations by using those defined parameters, and also they can assess the performance of the design options. This can hugely reduce the cost of running the actual design or running the actual implementations. And the simulation and analysis can provide better optimized design solutions. Prototyping is another angle because the AI can assist in the creation of rapid prototypes, and with the help of 3D printing design technologies, we can quickly prototype the engineering solutions. This can streamline the prototyping processes and shorten the development cycle. And during the process of machine and human working together, engineers can collaborate with the AI systems to iterate through design options more rapidly. And we can also utilize AI to identify anomalies. And in this way, that we can mitigate the engineering risks early, and allowing the engineers to adjust those risks before it becomes a disaster. So in summary, AI plays a crucial role in optimizing engineering designs by automating complex tasks, providing data-driven insights, and allowing engineers to explore broader range of possibilities. It enhances efficiency, reduces costs, and leads to more innovative and sustainable solutions in different engineering domains. So next, I give you a few examples, real-life examples, which are the actual works that has been done by Swinburne University and with their industry partners. So one example is the live inbound milk supply chain. So the problem is how to improve the production of milk quality and streamline the milk supply chain. So in this project, we have developed the world first milk quality sensor, on-tank milk monitoring device, and live milk supply monitoring solution. So in this project, we integrated our technologies of Internet of Things and backed up with those intelligent AI algorithms. and to streamline the production of the milk. And the sensors were produced by multiple companies, communicated with those infrastructure supported by those telco company, Optus. And this is the world-leading milk supply chain solutions by utilizing the AI technologies. The second example is about how we can reduce the time to identify and the roadside assets problems, and also to streamline the roadside assets maintenance. So this project is done by the Swinburne University together with those 5G support of Optus, and the actual solution has been implemented in real time in the City Council of Brimbank. We use the 5G to support mobile, high bandwidth, reliable machine-to-machine data communication. And the outcome of this project is to reduce the cost of roadside asset auditing by 50%, which is the huge percentage. Another case is about data-driven traffic analytics for incident analysis and management. Traffic analysis is a very powerful tool that can be used to analyze and manage or predict the road incidents. By analyzing traffic patterns, we can identify the areas of congestion, accidents, and other accidents that may impact the flow of traffic. The information can be used to develop strategies for managing those incidents, such as rerouting traffic or deploying emergency services. And this is the one research Australian Research Council supported projects done by the Swinburne's research data analytics team. And the last case in this category is about spacecraft autonomy and onboard AI chips. So nowadays in the space industry, AI has become an increasing vital tool. Spacecraft equipped with the AI board can perform very complex tasks autonomously, allow for more efficient and effective missions, because we are sending those AI algorithms, onboard AI algorithms, to the space, and often they don't have a very strong communication links to the ground stations. So we can utilize those AI algorithms for navigating those big asteroid fields for data and analytics on space. And the aim of this project is to develop those novel algorithms for AI-based space craft. So this project was sponsored by Defense and also SmartSat CRC. So I think that's the first category. And the second category is about how we can use AI for simulation and predictive analysis of complex systems. So AI can enable simulation and predictive analysis of complex systems by harnessing the power of data, algorithms, and computational capabilities to model and understand the different types of systems. So the AIs can perform model training, system simulation, and anomaly detection and prediction and forecasting. In the end, it can perform decision support. AI's ability to combine data-driven insights, advanced algorithms, computational power makes it a very powerful tool for simulating and predicting the behavior complex systems across a wide range of domains, from engineering and finance to healthcare environmental modeling. And this capability is valuable for understanding, optimizing, and managing complex systems more efficiently. So in the next few minutes, I give you some examples of how those monitoring system can be done. So one project that our engineering department has done is about how we can use optic fiber sensors to monitor the failures of the conveyor belt. So it can transform the failure signals remotely and to predict efficiently how those the engineering failures can be detected. And we have developed our innovative AI algorithms to provide early warnings of those failure. And we use the isolation forest supervised machine learning algorithms for those anomaly detection. And the second case is about how we can assess the health conditions of timber utility poles by utilizing different types of algorithms. So traditionally, we just use those visual recognition ways to identify the timber hole degradation. And currently, we have utilized computer vision and AI algorithms for assessment of those timber problems. And the inspection can be done very accurately by utilizing different types of devices, the tools and the sensors. And the collected data will be transformed to the backend server, and the backend server can utilize those AI algorithms for detecting the defects. Another example is about applications of AI in structural design and optimization. In this field, there's a technique called evolutionary computational algorithms that can design robust, powerful, reliable, however, very innovative designs. So you can see from the picture that we can design some beautiful structures, but those structures has a very strong strength, and they can hold different types of structures. And from the simulation to the real world prototyping, we have our 3D concrete printing facilities in our Hawthorne campus, and we can print almost about 10 meters long and wide real life concrete structures within our Hawthorne campus. So please feel free to come to our campus to have a look, and we can showcase how this 3D printing capabilities can implement the prototyping, engineering prototyping by using this real-life concrete printing. The last angle is about security, privacy, and reliability. So in today's digital age, cybersecurity has become a crucial concern for different types of systems, including manufacturing systems. With the increasing reliance on those interconnected devices and networks, the risk of cyber attacks has become real, and the risks grow very fast. It is essential to ensure all those different systems and devices are secure and protected from potential cyber threats. So in this project, we have developed robust cybersecurity countermeasures to safeguard the critical manufacturing infrastructure, sensitive data, and intellectual property. So Swinburne University and our partners, including Cyro Data 61, DXC, ESTA, Sysbox, AWS, have worked together on providing the cybersecurity solutions. So in this program, we not only develop technologies, but also train cybersecurity talents. So we are recruiting research students under this program, and the research topics are related to cybersecurity and engineering. So why cybersecurity nowadays is so difficult? I just want to use a very quick slides to show why this is so difficult. Because the number one challenge is about software complexity. So nowadays, almost everything is driven by software. However, the software is very complex nowadays. So we can see that different types of systems have the different types of, they have a lot of lines of source code. So for example, the Apple operating systems has more than 100 million lines of source code. So analyzing software becomes a huge task. It is almost impossible to go through all those different types of systems and identify the security issues within those software. The second challenge is about data. So nowadays, people generate data almost every second, and we can gather all those different types of data by utilizing different sensors. However, it is very difficult to label them, and it is very difficult to get insight from those huge amount of data. So this created the imbalance between efficiency, effectiveness, scalability of the actual knowledge within those data. So there's inefficient resources and inefficient security knowledge of analyzing those data. So that's why nowadays, although we do have our security concerns, but we don't really can understand the data behind or the intelligence behind the data. So nowadays, we really need to utilize the AI algorithms to analyze the gathered data, and also to have some reasoning power behind that to ensure security, privacy, and resilience. So I think I probably utilized the last slide to summarize the work that we have presented today. There are a lot of opportunities provided by the AI, the development of AI, because there are a lot of new solutions that are generated or supported by the AI algorithms. However, there are also some challenges as well, because nowadays we don't have enough AI specialized talents, and different fields work in different silos. And for example, in the engineering fields, people may not know that there are some new generative algorithms that can support different solutions or innovative solutions in different fields. And there are some impact to the future workforce because there are different fields that are needing people who can work on different fields. So for example, automation of routine tasks, efficiency and productivity, improved decision-making, predictive maintenance, and there are a lot of new job roles because the AI can improve the productivity and efficiency for different types of jobs. However, the AI can also create job opportunities. So there are a lot of new things happening, and I welcome everyone to joining the new trend of the AI and solve your domain problems in different engineering fields. So I think that's pretty much I want to talk. I want to thank David again from Australia-wide for this brilliant opportunity. And please feel free to ask me any questions. Thank you.
Fantastic, Professor Xiang. Thank you very much for your very interesting presentation. It's amazing how many diverse applications that you're able to just capture in a brief amount of time there. I think it does really demonstrate the huge potential that this digital transformation will cause and create, and the opportunities that will subsequently arise from it is quite incredible. So thank you so much for your presentation, Professor Xiang. Very interesting. And we do have some really good questions too, and there's still time. There's a few minutes left, so if anybody else has a question, please do text it in the box below. First question from David. Thank you, David. I think this is probably an easy question for you, Professor. Will AI enhancements create the risk for engineers to either lose their jobs or downgrade the importance of their roles?
Thanks for the question. I think this is a very good question because AI has been transforming so many domains, including engineering. So my answer to this question is that we probably wouldn't see AI as something replacing the current workforce. However, AI is actually helping us to provide more innovative solutions because nowadays, with the power of AI, we can relieve ourselves from those routine tasks and focus ourselves on more creative tasks. So in this way, efficiency or productivity can be improved. However, we can utilize our human intelligence for better or more creative solutions. So in this sense, I would say that AI is actually helping us to get more jobs done or better jobs done.
Yeah, fantastic. Good to hear. Good to hear. Another question from Marcus. Marcus, thank you. This one may be a little harder for you to quantify, Professor. Marcus asks, so far, how much is AI used in the Australian engineering market?
Yeah, I guess this is very difficult to quantify. We have seen some examples in the engineering field. So for example, I have just given a conveyor belt monitoring project. So the AI algorithms has been used in those monitoring field. So the AI can be used to detect defects or anomalies. So this is really a good examples of quality assurance in engineering field. Those tasks can be performed by AI, and often the AI can produce a better quality of monitoring. So I would say that we will see more and more AI-enabled work in the engineering field.
Yep.
And I believe that those AI-enabled tasks can probably produce better results.
Yes, yes. And as you explained during your presentation, it increases efficiency and allows people to delve into other complex problems. So yeah, no, the trend is clear. Emil, thank you for your question. Emil asks a very relevant question for our engineering audience. What is the pathway, Professor? What is the pathway for someone with an engineering degree to upskill or career change in this fast-moving, changing landscape?
I think different universities or different training organizations provide different types of offerings. So, for example, within Swinburne University, because at the Swinburne University, we provide a lot of opportunities of using different fields knowledge to address some specific problems. So at Swinburne, we have engineering degrees, computer engineering degrees, but also we have those related computer science related degrees as well. So the pathway could be some bachelor degrees, honors bachelor degrees, but also some coursework master's degrees and by research degrees. Just I want to highlight that at Swinburne, we provide a lot of scholarship opportunities. So you can do full-time or part-time study with the Swinburne, but also you can get scholarships. So I guess that's the one advantage of studying with the Swinburne, and another advantage is that every student here got a placement. So this is a very unique university.
Fantastic. No, very innovative and a leading establishment. Yeah, superb. The questions are coming in thick and fast, so we've still got a few minutes, so we'll try and tick these over as quickly as we can. Thank you so much to our audience for attending and also for all these interesting questions. Here's an anonymous one. What can businesses do practically to engage with AI experts, Professor, to understand where AI can help them in their operations? So a very practical question: how would a business interact and kickstart an investigation in this area?
Because the development of AI is moving very fast. Because in the development of those AI algorithms can be moving very fast. So which means you probably need some AI specialists to give you some time to assess the nature of your businesses. And then in this way, you can better utilize the technologies to address your domain problems. So and I would say that that is probably a quick way to identify what are the issues within the domain that can be addressed by AI, and what could be the weaknesses or strengths of utilizing AI in your domain. So I think that we probably we can utilize a human for assisting this kind of a process, but also there are a lot of online tools that you can play with.
Sure. Okay, we're getting lots of questions in regards to will this recording be shared? So yes, to everybody that's asking, absolutely, we'll be sharing this presentation, and all contact details will be followed. Swinburne and Professor do a lot of work with industry to help them solve these sorts of problems. So I'm sure Professor will be happy to be contacted subsequently. Another quick question from Abdullah: How would you calibrate AI performance itself? So I guess this is more a metric or measurement sort of question.
Yeah, this is dependent on the domain. So for example, the very popular domain is self-driving algorithms, right? So nowadays we can see the cars, the EV cars, such as the Tesla cars, they have their onboard AI algorithms. So how we can calibrate or we can test the AI performance itself. It depends on the tasks. So, for example, the Tesla algorithms, they actually they compare the driving behaviors of human beings with their AI generated behaviors, and in this way, they can further improve their automation processes. So it's kind of an evolving process, and the performance can always be tuned by different ways. It can be a comparison with human behaviors, or it can be a comparison with other AI algorithms.
Very good. Another anonymous question. How long will it take, do you think, Professor, for AI to replace generic engineering roles? The example given was reliability engineers. How long would you foresee potential for these sorts of positions to be replaced with technology?
I'm not sure how long it will take, but definitely it's moving towards that direction for some repetitive tasks or for some simple text or image processing tasks. AI can definitely provide some help. However, it heavily still rely on the domain knowledge. So we still need the engineering specialists to understand the domain problems and also to find the right solutions in different types of fields.
Chris, thank you for your feedback and for your question. Professor, do you think there's a risk of over-enthusiasm for AI over the next few years, similar to what happened in the 90s with the dot-com boom and bust? If so, how might this risk be managed? Interesting question, huh?
That's a very interesting question. However, the thought is not new because now we call those different types of algorithms as machine learning algorithms, deep learning algorithms, or whatever learning algorithms. Those algorithms are actually not new. They have been developed decades ago. So because the algorithms are not new, what new is that the application areas are new, and also the ability of obtaining data is new. So nowadays we are having a huge amount of data, which means we can feed those a huge amount of data into the existing algorithms, and the existing algorithms can produce more reliable results. So that's the new thing. So what I'm trying to say is that the evolution has been there for decades. So now people have better ideas about how we can harness the algorithms to produce better results.
Sure. Okay, we've got a couple of very technical questions, which I think Shane and Mohammed, thank you for your very specific questions. I might pass them over to the professor post the webinar, and time permitting, he will get back to you in due course. But thank you for your very interesting questions. Saeed asks, would Swinburne University support and sponsor new ideas on AI? If so, what will be the process? I guess there's a lot of overseas international engineers who have recently come to Australia looking to enhance their career, who perhaps looking to study
Well,
more in these fields. What's your response to that one?
the job that the university researchers do is to help our partners to solve their problems. So I guess we can definitely arrange some time. It can be myself, it can be our research teams within the university to understand your issues, your problems, and your new ideas of AI, and see if it works. I guess more discussion will be needed. But I want to highlight that Swinburne University is a very much application-driven university. So we do our research, but our research is probably more research and development. So we help our partners to address real-life problems.
Sure, sure. Lots of continued feedback here, Professor. Thanking you very much for your insightful presentation. Lots of very strong responses. Thank you. Vivek asks, perhaps this may be the last question. Vivek asks, again, quite an interesting question. And it goes like this. How could individuals from a manufacturing background who were discouraged from pursuing other fields due to Australia's offshoring of manufacturing, especially pre-COVID, be encouraged to re-enter the industrial and manufacturing industries in Australia whilst the emergence of AI technology is occurring?
That's a very good question, and I have seen a lot of support from the Australian ecosystem in manufacturing, and I understand that we should not rely on overseas productions, and we should have our Australian made by Australian productions for sure. So I think that there will be more opportunities, local opportunities within Australia, and Australia has been invented a lot of new things, such as penicillin, such as the black box, in aviation, and the Wi-Fi technology was invented in Australia. So we never short of innovative ideas, and I believe that with the support of the AI, we can definitely generate a lot of innovative solutions in manufacturing field.
Fantastic, great answer. I hope that answered it, Vivek. Last question from Shane. We'll squeeze this one in. Are there any short courses that Swinburne currently teach for an interest in AI, be it on campus or online?
We have on-campus short courses in AI and data analytics. And we actually have multiple courses. If you search the courses at Swinburne by using keywords AI, machine learning, or data analytics, you'll probably find those short courses. And nowadays, the university provides micro credentials, so you can take those different courses and get to know more things about AI.
Fantastic, fantastic. Professor Xiang, thank you so much for your time and for your insights and for your very interesting presentation. Audience, thank you so much for giving us your time and also for all your feedback and interesting questions. We will try to respond to the questions that we couldn't get to subsequently. And as a reminder, we will be sending out a link to this webinar for everybody who registered, for those that attended and those that had to miss it. But everybody that registered will be receiving subsequently a link to this webinar. Thank you all. It's been a very interesting presentation. Thank you and goodbye.
Thank you.